Woohoo! Hey, welcome back. In the recent end of the year Q&A video, I mentioned that I'm considering buying or getting a new lathe at some point in time. Well, that point in time has come way sooner than I expected. I was very low-key looking at lathes. And despite what I said in the video that a Weiler Primus is not an option because it has gear train directly to the spindle, which is wrong, well, I got a Weiler Primus. So let's start at the beginning. I was looking for a more heavy-duty, more industrial lathe with a quiet gear train, more rigid machine in general, and also with a lever action collet closer. We'll talk about that in a second. And the machine couldn't be too large because my shop is fairly small, but it needed to be a very good machine because I rely on a good lathe for the work I do. The MCO is an excellent lathe. There is nothing about it. It's a really good machine. It's not an industrial machine. It's the lowest tier of industrial machine, I would say. You will find this in something like a maintenance shop, sometimes in apprentice shops, things like that. Maybe an R&D shop. The Weiler Primus, on the other hand, is a toolroom lathe. This is a proper industrial toolroom lathe. Weiler is also big in the educational sector, apprentice shops, schools and stuff like that. Especially today, Weiler is still around. Still make lathes with a focus on education these days. And so that's what I got. What might surprise you, this machine is smaller than the MCO. The MCO has a distance between centers of 600 something millimeters. The Weiler is, if I take the chuck off and I put a center in it, center distance to the tailstock is 450 millimeters. So it's a smaller machine. It has a 20 millimeter through bore compared to the 26 millimeters of the MCO. It has less center height. The MCO can swing a 280 millimeter part over the bed. The Weiler can swing, I think you can get it to swing a 250 millimeter part. On the other hand, the Weiler weighs almost double what the MCO Super 11 weighs. It has one size larger spindle taper. This one has a short taper number 3, which is the same taper as on a cam lock spindle, just with a different locking system. This one has a size 4, which is more standard size. Size 3 is a little bit of an outlier. Relatively hard to get tooling for it. Well, you can get tooling for it, but it's not as common as size 4 and 5. I mentioned already the quick action collet closer. This is nice. And also the speed range. The MCO is 0 to 2200 RPM since I put a VFD on it. That makes it stepless adjustable with a gearbox, so I have very high torque at low ranges. The Weiler is a gearbox machine too, 2-speed motor, 3-phase, 1.1 kilowatt on the slow speed and 1.5 kilowatt on the high speed, and has a speed range of, I had to look, 60 at the lowest gear speed and first motor speed, up to 3000 RPM, so it's a faster spindle. The designers of the Super MCO have forgotten that you have to lubricate the bed slide and all the sliding elements. There are no provisions for that. On the Weiler Primus, you have oil fittings on everything that moves and well lay out oil lines and oil grooves to get the oil where needed. The spindle is driven via a belt from a gearbox, so you do not have the gear noise on the spindle directly. It doesn't make much difference, to be honest. The spindle of the MCO runs very, very quiet, but not in a noise level. This machine is a little bit louder, in fact, but with the artifacts from the vibrations from the gear tooth on the MCO, you get a tiny bit of artifacts in the surface, and I expect this machine to not do that because it's belt drive to the spindle. It's sitting on the factory stand, which is nice because this is set up for coolant. It has a full drip tray, no oil mirror on the floor or coolant that drips off the machine to the floor. It has a pump, it has a coolant line, there's a lock line up here for the coolant, so that's all nice. Weiler had a habit of putting extremely long compound slides on the machines, and I will talk about that in a second because most of you will probably expect that I'm going to remove it and put a solid tool post on it. But I want to try something else on this machine. It's of course, it has a feed gearbox, also for, this is a gearbox for power feeding and cross feeding, and also for threading. So we have our lead screw, and down here is a power drive shaft to drive the power feed. Tailstock Morse taper 2 is basically the same. The bed is way heavier than on the MCO. So over here on my venerable MCO lathe, and let's take a look at the bed. And just, as you can see, MCO has decided for this fairly thin diagonal ribbed bed design, which is fine. It's not ideal, but it works. But let's go over to the Weiler. And Weiler decided to do this huge box webbing in here. Let's crank the bed slide over here in a very short distance. And since this is a way larger cross section than the thin webbing on the MCO, this bed is substantially more rigid. Let's see, 155 millimeters. And the bed on the Weiler is also 155, but the bearing surface here is super wide, and we have a square surface which takes the side forces front and back. It's adjustable with Gibbs. Yes, boxways have a drawback. They are not self-aligning or self-adjusting against side-to-side play. If there occurs wear on these surfaces here on the sides, you have to adjust, and you can get into problems where the ways are loose in one spot and are tight in the other spot. On a prismatic way like this, it's self-adjusting, because when you have wear on these surfaces or on the mating surface on the bed slide, it just drops down further onto the bed, but it's still free of play. Of course, it can still rock if it wears like a pillow, or it will also influence precision, but it will not have side-to-side play. But since these are hardened rails out of tool steel, these have a very long service life, especially if you take care of them and don't do dump stuff like having grinding grit on them and then crank the compounds or the carriage over it. And also you have to make sure that the wipers here are always in good condition. So you take like a 10 micron shim stock and just test if the wipers still make contact with the way. If they don't, replace them immediately. And here is the bayonet locking system of the spindle. Super simple system, works very well. With little short section of lock line here. 2 outlets for machine light and DRO. Cam lock for the tailstock. Adjustment, the gib for the tailstock. So it's running free of side-to-side play. And yeah, that's it. It's a very simple machine. Down here we have some accessories. We have the collet set. some change gears, and a original Röhm short taper 4 backplate. Also, this is not a V flat way like the Emco. This is a box way. There are 2 hardened rails bolted to the casting and ground. Speaking of ground, this machine is built in 1995, so it's very new for a machine in my shop. But it has been rebuilt. It has been recently rebuilt by Arnold Werkzeugmaschinen in Langenzenn, which is close to Nuremberg. A complete rebuild. Ground every slide, every dovetail is ground and rescraped. Electric paint, all the wear items like bearings are new. The spindle taper is reground. The taper in the tailstock is reground. It's just a once over. It's basically like a new machine. And you pay for that. When I was looking for a machine, I was looking for a very good used machine. And I called Arnold if they have something in stock, and they had one used machine and this rebuilt machine that they actually did use as an exhibition machine for trade shows. They dragged this from trade show to trade show to show off what they can do on machine rebuild. They are, by the way, the same people that I got my FP1 from, the Deckel milling machine. So I'm rather happy with them. So I called them, they said they have one used machine and one completely rebuilt in stock. And I drove there, I looked at both machines, and I decided, after a good friend told me to ignore the used machine and just go for a rebuilt one because I used them to make a living. I looked at this machine, we talked a little bit, and I decided to come back with my own tooling and materials and just do some cutting with it and see how it behaves and see how I like it. If it's more rigid than the Emco, spoiler it is. And I came back, did that, and on the spot I decided to buy it. If you ask for the price, it's less than 30,000 euros, I will say that. Electrics have been completely redone. It's on the current level of what's needed to be a safe machine in an industrial environment. It has the chuck guard wired into the emergency system and whatnot. I didn't buy much accessories. I only got the collet set, the reducer sleeve, the collet closer. This was not on the machine when I looked at it first. They put it on for me. And I got also an additional chuck backplate and some change gears and a manual. And transport with crane, because my property here is a little bit hard for forklift or to pallet jack a machine from the driveway to my shop. So like the Deckel FP1, I had the machine come on a truck with crane and had it lifted over. So then it was a very simple pallet jack operation to get it here. So currently it's not in its final place because over there the Emco is still where it is, because that's the machine with a DRO currently. This machine doesn't have a DRO yet. I decided to put the DRO on myself because Arnold offers both Heidenhain or K&C. I wanted to go for Icron, which I already have on the Deckel milling machine, so I can swap either linear scales or readouts if something goes bad. So it's nice to have two similar systems, so I'm able to swap around. RAN certification, guarding of the ways and things like that. Before I start doing that, I want to use the machine and see what I want to do. There are some spots where I want to do guarding, and I'm not sure yet if I'm going for a full bed guarding here, but it might happen. So time will show. It's very nice to have everything guarded, and you don't have to be two concerns about, for example, chips, very fine chips from hard turning, or when you use the ID grinding spindle to grind carbide, to get carbide dust on the ways or things like that. But we have to see, because in some kinds the guarding is a little bit limiting sometimes. It's always a trade-off if you do stuff to your machines. What else? So let's take a closer look at the machine. Okay, let's look at some brochures about this machine. The Weiler Primus Lathe and Zugspindel-Drehmaschine and the Primus Mechaniker-Drehmaschine. There are two basic versions of the machine. One is the regular, let's zoom in a little bit. One is the regular version with the lead screw and power drive for turning and screw cutting, and the other one, the Mechaniker Drehmaschine, is the one without a lead screw or power drive. So it's basically a plain lathe without the capability to cut threads or power feed. Also, you note that there is no gearbox for the feeds, and also there is no selector switch in which direction to run the feed. You only have the carriage with the carriage hand wheel and the cross slide on these machines. These are for very basic machining. So that's the two basic versions. But then you also had the option to get it as a benchtop machine, standing in a nice little grip tray, and the electric box is set up here on the side. This machine here has the auxiliary electrical fine power feed attached, which is an accessory that you don't see very often on used machines. And there was also the option for a sliding chuck guard or spray shield that runs on a rail in the back here. And I think that's a fairly nifty design. That's more something that you would expect on a CNC machine, like on a Toolroom CNC lathe. So I have to say the machine looks pretty sharp in 6011 Reseda green. Here you can see the feed gearbox. It's not oil filled, I was mistaken there. It's a greased gearbox that's running not in an oil bath. And up here we have the spindle drive gearbox with the belt drive going to the spindle. This one runs in an oil bath. Here are the different options. Electrical power feed. The chip guard was an option. It's quite a clever solution running on the rail back here. Also, this was their options for a digital readout. This is the old school Heidenhain with the red 7-segment LED display. And here the two spindle options. This one is camlock spindle, camlock size 4. And standard, it came with the short taper 4 with bayonet disc. I also had the option to attach a mill head to make it a pseudo improvised milling machine. I always thought this is a reaction to the Emco Super 11, which also had a very similar contraption that you can bolt to the backside of the bed. I think it's a crutch. Yes, it gives you some milling capabilities, but having to change everything over, you have to remove the compound, put the T-slot table on here, and that's an awful lot of work and an awful lot of time that goes to nothing. So I think this is more of an emergency solution, and it looks nice in the catalog if you have it. Here you can see how it's mounted to the bed. The full lineup from 1990. We have their manual lathes, Spitzendrehmaschinen, Primus, that's my machine, smallest one in the entire lineup, the Praktikant, Condor, and the Commodore. These machines basically get larger and larger each step up. Personally, I have used the Praktikant and the Condor at my day job, and also we have Matador and the Praktikus, which is an older machine that's not in this catalog anymore. The Praktikant is really a very nicely laid out machine, really good general size machine for toolroom and machine building shop. The Condor I despise. I do not like this machine. It's The layout of this machine, it's a great machine, of course. It's really well built and very stout. But the way the controls are laid out, I don't like. And the Commodore I have never seen in person. At this point in time, they still made plain lathes. Very old school looking, with the rounded castings, belt drive in here down to a motor in the cabinet. No carriage, just cross slide up here. They even made a lever operated version over here and a lever operated and capstan version over here with a thread chasing attachment if you wanted to do production, which is quite the contrast. The contrast between this machine or this machine and, for example, the Weiler Praktikant is significant. And I'm noticing that there is something odd with the Praktikant here in this picture. There are two multifix holders and something on the back here, but in this picture there is the taper attachment mounted to the back of the cross slide. That's odd. That's an odd choice for a promotional picture. And of course they had CNC lathes, UD24, 42. These are slant bed machines. We had the 24 in the apprentice shop at my former day job. And then they also made a CNC version of the Primus, but this is a completely different machine than the manual Primus. This is a slant bed machine with a turret. But they also made the Weiler 120 CNC, which looks very much like they took the parts of a Weiler Primus manual machine and just converted it to a CNC machine. At least it looks extremely similar from the general layout. We also have a price list. Price list, 15 January of 1996, still in Deutsche Mark. We have the Weiler Primus LZ, which is 24,400 Deutsche Mark. I put this into a currency and inflation calculator and came at current price of 20,000 euros, pretty much. Okay, here's some farting around with some different tooling in some L2 drill rod, or 12210, if you want to be a little more precise. Just playing around, and the machine is significantly stiffer than the MCO. There is nothing about it, it's just way more machine than it looks like. The 2mm inserted grooving tool that I used in the previous shot did not run as well on the MCO. Or here, plunging with a 10mm diameter carbide insert into tool steel. The MCO did that too, but with the solid tool post and with an extremely low speed. I had to pull the speed down on the Weiler here too, because as the engagement of the insert gets bigger, it's just adding more and more strain on everything. This is just a cut with a finishing insert in the drill rod in increasing depth of cut. Since this is a finishing tool or a finishing insert, it's not very good at breaking the chip, which you will see in a second when I take a 1mm depth of cut. Or 2mm. Too much for this insert. This insert is really not made for removing a ton of material. But I'm just farting around here. Also, let's do a short pass with, I think this is 2mm depth of cut once I reach the shoulder. And the machine does not really care, but the insert is not happy. It doesn't break the chip, it just creates this noodle of chips. Here again with the grooving tool, just parting off the excess material. Especially grooving tools will really benefit from running flood coolant. Inefficient cooling and lubrication on parting and grooving tools is, in my opinion, 99% of the problems that people have. When I see people try to part off without any lubrication, that's calling for trouble. The Weiler Primus is a very, very basic machine. It doesn't have any unicorn features. It has, as usual, a bed slide running on the 2 hardened rails. We have the bed slide with the power feed. We have the cross feed with power feed again. We have the half nut for threading, and we have the compound slide with a huge engaged length of dovetail. So these dovetails or these compound slide on these machines are fairly rigid. The drawback of a compound, of course, is that you tend to lose, first of all, your alignment of your tool holders, especially when you want to do drilling with the carriage. And also you lose your zero from all your tooling when you move the compound. Especially if it's an angle, then you lose both C or length and diameter offsets on the DRO, so that's a problem. Comes with the same multi-fix size A that I have on the MCO. This machine does take a little bit smaller tooling. The way I set the Super 11 up, it can take up to 16mm shank tooling. This machine is built for 12mm tooling. So that's the carriage, and you see all the fittings here, the circ fittings. These are for lubricating all the moving elements. We have the tailstock, Morse taper 2, with a nice quick action clamp. And well, it's a tailstock. It's a good place to hang the air hose or to do extremely heavy drilling compared to the compound slide. And also the machine, of course, has a stop so you don't run the tailstock off the machine. The chuck that's currently on here is a new to me Centra 125mm steel body 3-jaw chuck with fine adjust. I want to use this chuck mostly with soft jaws. So I got a set of master jaws along with the regular jaws, so I can mount soft jaws to it. I need a soft jaw chuck for certain kind of production parts that I do for a customer. So that's absolutely necessary. As it's an adjustable chuck, but when you run soft jaws, you do not really need the adjustment feature. But at the time, this was the only steel body chuck that I could get in time, in the right size and in a reasonable time frame. So I figured the chuck with the fine adjust is a nice bonus if I have to use hard jaws in this chuck and want to adjust the run out of a part. I ordered a second back plate to go on the spindle nose of the machine. I will also put my 6-jaw chuck from the MCO on here again, but that's still on the MCO machine because I still use it. The chuck mounting of this machine is very similar to what I had before, but better. It's not a cam lock spindle. They made these machines as an option with a cam lock spindle with 3 cam lock bolts. But these machines are different. They have the same taper as a cam lock spindle, but they use a bayonet disc. So let's get the spindle spinning free. Lock it. So you loosen these 3 bolts. This is a little bit slow because I'm working around the camera. And then you just twist this knurled ring here by a few degrees, and then you can lift the entire chuck off like this. Once you get the hang of it, this is an extremely fast chuck mounting system. In my opinion, it's not slower than using a cam lock spindle, because with a cam lock spindle you also have to index 3 times to get your wrench in 3 times. But I find this a more reliable and more simple way of mounting accessories. It has more CP4 in the spindle, and we have a collet system. This is not 5C because the spindle bore is too small for 5C, to take the 5C directly, which is fine because I always can put a 5C chuck out here like I have on the MCO. And I will most likely get one because I have a lot of 5C accessories. Let's clean the spindle taper. So here is the reducer sleeve for using the collet system. These are B23 collets, or depending who you talk, also W23 collets. I'm not entirely sure what's the deal there. Oops. As with, it's basically the same system as a 5C spindle. It's a keyed collet, and you have a drawbar on the back of the machine. And if you're a little bit adventurous, if you're a little bit lazy, you can run them in under power if you are very, very careful. Do not recommend that, of course. Then you can just simply put your part in and you adjust the collet. Takes a little bit of practice to get the collet pressure right here. So that's the right collet pressure now, and then you can just boop, go in and change your parts extremely quick. It's it's not interlocked, but it's mechanically locked, so you don't accidentally open and close it. You can if you know what you're doing. Change parts while the machine is running. I do not recommend that. Nobody should do that, but some people do it. As I said, would not recommend it. But that's a feature that I really, really, really wanted on this machine, and I was looking forward to it very much because I'm doing an awful lot of collet work. The 5C collet chuck with the wrench is relatively slow if you have to do a large amount of parts. Here's the back side of the machine. This is the drawbar. This ring here adjusts the stick out of the collet so you get your correct clamping pressure. And if you want to undo the collet, you just spin this about 500 times counterclockwise, or run it out under power. Again, I do not recommend that, of course. Trained professional on a closed shop. This, of course, obstructs part of the spindle bore. It reduces the spindle bore from 23 to, I think, 16 millimeters, something like that, or even less. So if you want to use the full spindle bore, you have to remove the draw tube. So let's have a look inside the box here. We have one screw that needs to be loosened. Then we can finagle this around all the stuff in my shop. And in here is the drivetrain of the machine. So up here this is the collet closer mechanism. It's basically pulling this tube, which is a pipe with the drawbar thread in on the end, pulls this out and clamps the collet. Here is the double V belt. There is a myth going around that it's hard to get these paired and matched V belts, but I was told that it's an absolutely no problem. Just talk to your belt guy. So back here is the gearbox. This is an oil-filled gearbox, which allows you to do all your speed selection. Up here. And the gearbox is driven from this humongous 1.1 1.5 kilowatt motor, 3-phase 400 volts. And this is driven via a belt on the opposing side behind the guard. Change gears for certain speed settings or certain feed ratios and thread pitches, you have to use change gears. Also, you have to switch the 120 tooth gear to a 127 tooth gear for imperial threading. And we will find that very soon because I have to do imperial threading. This knob up here switches on and off the output shaft for the power feed and thread feed. So also changes the direction of the power feed. Also, you use this to do left-hand threading, of course. You change it around. Also, you can completely lock the spindle using it if you want to mount the chuck. Or you put it in neutral and then the entire drivetrain down here doesn't move. The cover here is interlocked electrically, so you cannot put your finger in here and turn it on, which is nice. The headstock itself is not oil filled. There are two large scale taper roller bearings in there, which are lubricated with some Kluber NBU 15 grease. Should be good for 5,000 hours or something like that. Electrical installation of the machine. Come up to the machine, main power switch. Then you turn on this. This is the control circuit, which also is the emergency circuit. If you hit emergency stop, it drops everything and you have to turn the control circuit on back again manually. You have the two speeds of the motor, the brake, it's a braked motor, and the coolant pump. And up here, this is spindle on, left and right. The large ka-clonk noise that you hear, that's a spindle brake. So the idea with the brake is you can either run the machine completely without a brake. It just goes to a stop from the friction in the entire system. That's very nice. This can be useful if you do faceplate work, for example, and you have parts bolted onto a faceplate and which are fairly heavy, and the rapid stop of the braked motor could shift parts on the faceplate from the inertia. So that's, or you just don't want to hear the ka-clonk noise all the time. Then we have the setting. This is the spindle still not brake. Without a brake, but you turn the motor off, then the brake engages, stops the spindle and disengages again, so you can freely spin the spindle. Then we have a third setting, which is always on for the brake if the motor is not spinning. But usually I like it just like this. And it disengages the brake. That's my preferred mode of operation on these machines. That's once again, Weiler lathes are something that I'm kind of familiar with. We used to have the larger machines from this series at my day job. Weiler Practicus, Praktikant, Matador and Condor. All the larger machines. I have never seen or used a Weiler Primus before I touched this machine, which is quite nice. And of course we also have the compound slide, which is a very, very large one. And this is 360-degree rotating. For whatever you want to do. The parts I'm making currently, or that I'm doing as a production job, would benefit greatly from having a DRO on the compound slide. So I'm going to put a linear scale on the bed slide, on the cross slide for diameter, of course, and I'm going to put one on the compound up here because I'm doing angled or compound work on a certain kind of parts a lot. And that will be extremely beneficial. All the holes for mounting linear scales are already here. This machine used to have linear scales in the past. It was an ancient Heidenhain system as far as I know. Funny detail, they put the machine on some wooden blocks for shipping, and so I can grab it with a pallet check lengthwise, as you have seen in the transport picture. But this also puts the machine at almost the perfect height. It's almost a little bit too high up for my taste, especially for running the collet closer. I would prefer the machine to be a smidge lower. But I think I'm going to put it on either extended machine feet out of some large diameter round stock, or I'm going to build a nice base out of hardwood or solid wood. So the machine has, of course, this chuck guard, which is nice if you run coolant or oil. I plan to run oil, but we'll see. This is nice, but these are kind of fragile. These are made out of polycarbonate, and they tend to explode if you do something wrong or dumb. For example, if you have a tool clamped here and you leave the wrench on here and you power feed into this polycarbonate cover, they tend to shatter and just explode. And they are not cheap. They are like 150 bucks a piece, and I have broken more than one in my career. They can be removed very simply by opening up 4 set screws back here, but it's still rather annoying. I'm not sure if I'm going to leave it on the machine. Maybe I put it on if I need it. They make a replacement out of sheet metal. I ordered that at one point at my old day job for a Weiler Praktikant. The sheet metal one is nice because it doesn't explode, but also you don't see through it. So again, drawbacks and advantages outweigh each other. So most of what I wanted to talk about this machine. Yeah, solid tool post. I have an idea that I want to try. Guarding, I will look what I'm going to do on the machine. DRO, yes. ICRO, probably, or most likely. 3-jaw chuck, the 6-jaw from the MCO lathe. Yeah, so that's my new Weiler Primus Toolroom lathe. Weiler and Deckel are kind of the 2 household names for toolroom machines here in Germany. In Switzerland, it's of course Schaublin. In the US, it's Harding, and I'm not sure about a proper toolroom mill in the US. Probably a Bridgeport. It's very country specific which machines you see. For surface grinders in Germany, it's, for example, most of the time. In a tool room, it's very much Jung. In the US, it seems like the 6x12 and 6x18 surface grinders by Herrick or Parker Majestic, for example, are more common than here. So always depends on where in the world you are. And if you are in the US and you look at all those cool machines that we have in the EU or in Germany, it goes the other way around too. We look at all the cool Hardinge and the small Herrick grinders and think, oh, those would be cool, but we don't have those. That's also the reason why I didn't go for a Schaublin or a Harding in the end. Harding is super rare here and hard to find and hard to get, and replacement parts are even harder to get. Schaublins are outweighed in gold, approximately. Gold might be a little bit cheaper than Schaublin parts. I also had a quote for a Harding clone from Taiwan, but that was in the end about as expensive as the Weiler. So, and I'm not too sure about the Taiwanese machines. And to be honest, the Harding or Harding clones are a tiny bit big for my shop. It would be hard to press it in. This is a little bit smaller than the MCO, so I appreciate that a lot. This will give me a tiny bit of space back. So that was a brief 44-minute overview of the new machine. And one concern that I read out of the comments was that my channel might get unrelatable for hobbyists and home shop machinists. And yes, I hear you people, I hear you. I see your concerns, and all I can say is I hope that despite the machines getting better and better and more, well, quote unquote, higher end, despite that, I hope that the processes and my workflow is still applicable to used machines and machines that are more prevalent in the home shop. A lathe is a lathe is a lathe, no matter if it's a benchtop machine, a rebuilt Toolroom lathe, or a CNC lathe. The general process stays the same. It's a static tool with a defined cutting edge digging into material that spins. And I think that many things that I show are transferable to all kinds of machines and different parts. And that's what I'm trying to convey. And well, I don't see myself as a teacher, but I think there is something to learn on what I show. So that's that. Make of that what you will. This is not a showroom shop. This is a real machine shop. So I kind of need very good machines. Thanks for the ongoing support. That's what helps to keep the lights on the YouTube channel going. I'm not promising a video schedule fixed, but I try to do more than one video a month. Thank you all for watching, and I'll be back.